We proceed. Still with 12 and 1.
So,
Hello.
yes, I wanted to ask on the point that you said about how to get the maximum values, where you said vertical shift plus the amplitude. What for example here where you said 0, I mean, yeah, 1 plus 0, which is 1, right? On the positive part. Don't you think it's just the opposite of the negative? So meaning that if you have 1 down there, meaning that you're going to have a negative number.
If you have 0 as the vector, so sometimes the vector is 4. You have 4 minus 1. You get 3.
Oh, okay. Okay.
Okay, so we have so f of x is equal to root 3 over 2 if f is given as cos 2x minus pi. So we equate. We say cos 2x minus pi is equal to root 3 over 2. So you let theta take a position of 2x minus pi. And what you do, you now have cos theta is equal to 3 over 2. And then find theta. So which theta now gives us a 3 over 2 for cos? I get a triangle. One that has a 3, there's a 3 here, it has 2 here, it has 1. And that's 60, 90, 30. And this is cos. So cos is adjacent over hypotenuse. So adjacent, that has 3, and that's 30. So we get theta to be 30. That's in the first quadrant. Then you check where else is theta? Because I mean it's cos positive. In the fourth quadrant, so in the fourth quadrant, we say theta is 360 minus 30, which is 330. So these two values of theta that we have, you bring them back here because your answer must be in x form. So you say 2x minus 180 is equal to 30. So what is 2x? So 2x is equal to 30 plus 180, meaning 2x is equal to 210. And divide by 2, by 2. So x is equal to 105. The other one, 2x minus 180 is equal to 330. Take this to the other side. You have 2x is equal to 330 plus 180. That is 2x is equal to 0. 8 plus 3, that's 11. And remember 1. 3 plus 1, that's 4. Plus a remainder, that's 5. So 5 10. Divide by 2. Divide by 2. So x is equal to 2. And remainder 1. That's 5. 5. So these are the two values of x that we are putting in our solutions. So you don't use 2x minus pi as it is. You first use it in that form.
What if we found the value of x to be, since we're given that the interval it's up to 360, what about if x is above that?
What if you are?
If x is above 360, what do we do?
Because the question says 0 should be less or equal to x, so it should be less or equal to 2 pi, which is the simplest. So you let theta be 2x minus pi, and then substitute theta, get the value of 30 and 30. Then equate 2x minus 180 is equal to 30. Then make x the subject. Take on the other side, divide by 2. So Masa is asking that what would happen if we got a coterminal of 30? What for the coterminal of 30? You know the coterminal, you add 360 to the given angle. So 30 plus 360 would come out to be 398. That's a coterminal. And then you say 2x minus 180 is equal to 398. So take it the other side, you get 2x is equal to 390 plus 180. So we're getting 0, 9 plus 8. That's 17. Then 1, and then 4, 5. 5, 17. If I'm done for partition, 0, yeah, then divide by 2. To get x is equal to 2, 8, 5. It's within the range. It's part of the solution. And in most cases, if you see that there is a 2, you see that your x is being multiplied by some number. This number is going to tell you whether I should look for coterminal or not. So, you still have to get another coterminal there. Let's get the coterminal for 330. Coterminal for 330 is going to be 330 plus 360. You get 0, 9, 6. So we have 2x minus 180 plus 6. Let's see if it makes sense. 690 plus 2x. To add here, we get 0, 7, 8, 7, divide by 2. This has gone beyond this is 455. Greater than 360. So we don't get there. So I'm answering the question that was saying, what if you find x that is bigger than 360? Now, our solutions are only these 105, 285. Okay, let's go to B.
So, sir, for this question, how can you know that I'm supposed to find all these 3 values of x?
You're looking at the space. Your answers must be between 0 and 360. And we have found 105 and 255. There's still bigger space to 360. That's why we think of adding a 360 to theta and check what you get.
Okay, sir, very much.
Sir, I'm not very clear. Is it necessary for you? Does you equating the 2x minus pi to q help you in solving?
Yeah, it makes sense.
Then I get that also. I get the I followed. Then after that, I just don't know. After we say cos a cos q is equals to root of 3/2. I don't know. I know that's equal to sin 30 because of that triangle. But these my equations down here. I don't
This
understand.
theta that you find here, after finding the theta, then you remember that if you introduce the theta, initially there was 2x minus pi. So you say let theta be 2x minus pi. The theta you find, you equate it to the 2x minus pi that was initially in the equation. And then make x the subject. So when you get the 30, then say, oh, this is theta. But I said theta is equal to x minus pi. So what is x? Then you solve for x. Again, theta is 330. So theta is equal to x minus pi. So 2x minus pi, which is 180, is 330. So what is x? Then you find x. You check again, you get the coterminal of 30. You get 390. This is theta. So theta is equal to x minus 180. So again, you solve for x. You have the solution. That's what we need here. B, part 1. Simplify.
So before we go to B, I have a question. In an instance whereby you're not given an interval, then you're told to solve an equation. So how many values can you give for x?
You just give those that are in the quadrants.
Sorry?
You give those that are in the first 4 quadrants.
First four.
First 4 quadrants. Oh, we have this quadrant, is it? If there's no interval given, and I'm dealing with cos root 3/2, I'll pick an angle here, and here where cos is constant, just 2 values will be done. But well, for any equation, you'll be given an interval. So you don't have to worry about the interval, they always give you one equation.
So sir, if maybe confused on this one. So if you for example, maybe you only have, you're allowed to go beyond what you've been given just for you to get those 4 values. For example, maybe you're told to find for cos. You know that maybe cos is only positive in first and fourth quadrant. So what do? Are you supposed to go beyond for you to get those 2 other values?
When you say beyond, what do you mean?
Since, for example, like I'm finding for cos, I want to find the value for maybe for cos. I know that cos is only positive in the first quadrant and the fourth quadrant. Then you said if I'm not given an interval, I need to provide 4 values for x. So does it mean that I have to go?
If there's no interval,
Sorry?
provide 2 values of x.
Okay, all right. I
If
got you
there's no
said 4.
interval,
Okay.
you get from the first 4 quadrants. So because we only have plus, we will get from the first 2. If we had plus or minus, we could get from all the 4. That's what I mean.
All right. Thank you.
Where did 690 come from? 690 came from adding 330 plus 360. The coterminal of 330. What is a coterminal? It's an angle that you add the full oscillation. An angle obtained after adding 360 or an angle obtained after subtracting 360. Okay, B part 1, simplify. So away from trigonometry. Simplify A and B intersection A and B complex. So you distribute. So you have A and B intersection A. I've done A and B intersection A. Then I'll do union. So union A and B intersection B complex. That is A union B intersection A. So let's give us A. So one, A union B intersection B complex. A, B. A union B is everything here. Intersection B complex. This piece. Outside of B in A union B. In that piece is described as B complement intersection A. And then A union A intersection B complement this is A. By absorption. Absorption
So-
says, hello.
So
Please repeat.
yes, I wanted to ask on those answers. Like when you are done solving them, do you even illustrate by saying by the law of absorption, or you just write it as the way you've written it?
That's why people.
Okay, thank you.
So absorption says if you have this, you get A. And if you have this, you still get A. Whatever they say is, for as long as A is appearing twice and they have different operations, then A absorbs expression. So we have A union B intersection A. So use absorption, we get A. Then here we have A union B intersection B complement. We just get A intersection B complement. As seen on the diagram there. And then this again we apply absorption. So we get A, yes.
So why isn't absorption applying on the other one? Because they're similar. We have a B common.
Which one is common on the other one?
On the other side, A union B intersect B complement. Isn't the B common?
These one are very ones.
For
You
this
have
one, I
you have
think
A
it
union
would be
B.
easier.
You have A union B intersection B complement. B complement is not the same thing as B. So nothing is repeated. So you can't apply absorption.
Okay.
Sir, are you using a shortcut? I think you should try to explain more on the second step.
So for this one, I think it would be easier if you factored out A union and then you intersect the B and B complement.
So if you don't go with distribution, you do you say, okay, A is common together with its union. Then what is remaining? B intersection B complement. And this is empty. So you have A union empty, giving us A. Now it's easy. Thank you for that. What about this one? A complement union A intersection B complement. So you distribute the complement. So A complement is just A. And this guy changes the intersection. And then we have A intersection B. Complement. So now if we have this, then it means that this is A intersection B, and this is A. So what do we get? We get A intersection B. There's no shortcut there. We have it. We have A intersection B as a subset of A. In your intersection. So we get A intersection B. What do you mean by the second A? Could have a complement. The complement is not for A or for B, it's for everything, it's outside the brackets. So when this complement comes in, it will take away this complement. And so the brackets will be unopened. Okay. Another question. Question 3. A is not part of the coverage. This is statistics. So it goes straight to B. Let F be 2x plus 1. That is if x is less or equal to -1. And x squared minus 2. That is if x is greater than -1. No, it won't change because look, the complement is outside. Then you hit it by another complement. It disappears. They didn't go inside. It would change if you took it inside. But it hasn't gone. What we have is A intersection B, complement. Once I have double complements, they all disappear. This is the same thing as A intersection. Okay, so we're given this function. Part one says sketch. And part two, find the limit as x goes to -1 of f. Part three is f continuous at x is equal to -1. So I start with a sketch. Part one. To sketch piecewise functions, it must be the easiest thing to do. F of x is equal to x plus 1 and x squared minus 2. If what? If x is less or equal to -1 or x greater than -1. So you go to this number here. The numbers they put here. Put them on the x-axis. We have -1. And what do you do? When it's less means you're going this side. So pick -1 and substitute in the first function. So we have f of -1. Here where it is included. We're getting 2, -1 plus 1, giving us -2 plus 1, which is -1. So we have found -1, -1. It's closed here. Why closing? Because it's less or equal to it's included. And then the question says, when x is less, so I can't use this function to substitute a number that is bigger than -1. I look for numbers less than -1. So I look for numbers like -2. What do I get? I get 2 by -2 plus 1. That's -3. So I know it's going down. That's the reason why I wanted to substitute, just to know where it is going. It's going down because I'm getting -3 if I use -2. Even if I don't indicate that point on the graph, it's okay. Then, so we're done with this one. We got the right. What's happening when x is greater than -1? I pick -1, substitute in this function. So I'm doing f of -1. I'll get -1 squared minus 2, which is 1 minus 2, which is -1. So -1 is giving us -1, but the good point here is that the first function closed. The second function is just seeking to use this point -1, -1 as a starting point, not to include it. So it has nothing to do with its closeness. You just start from there. Okay. Then you pick a number that is bigger than -1. If 0 is not interval, it's 0. So we get 0 squared minus 2, which is -2. So -2. This is going to come here. The quadratic is very important. This value here, you can easily find it. We equate x squared minus 2 to 0. And we get x squared is equal to 2. So x is plus or minus 10. And of course, you can't say minus here. So you say plus the root 2. And you're being asked to find the limit. Is the limit. So what is the limit at x goes to -1 of f?
So,
Hello?
why has it gone up? What did you say? After finding the -2. Why has it gone up?
X squared minus 2 is a quadratic. The quadratic has that behavior. It's not a line, it's not a straight line. It's a quadratic, the x squared. Remember, we graph quadratics, they're either going down or going up. When do they go up? If the coefficient of x squared is positive, they go up. If it's negative, they go down. what that is. And then find the limit as x goes to -1. So of course, because we are having this curve, I can find directly as you go to -1 from this direction, the function is getting closer to -1, the value of x. So f of x, in the direction, we're getting -1. You're coming from this side, the function is coming to -1. From either side, it's going to -1. So I get -1. And then you check, is it continuous? When is it continuous? It's continuous if f of -1, in this case, f of -1 is -1. Is it equal to the limit as x goes to -1 of f? Yes, the two are equal. So f is continuous. Remember, continuate. What we need to know? We are checking one, if f of c is defined. Two, if the limit as x goes to c of f exists. And three, if this limit as x goes to c of f of x is the same thing as f of c. These are the cases, then the function is continuous. That's how you deal with this question. To find the limit, you are looking at what is happening to the graph as the values of x change. So as the values of x are getting closer to -1, what is the graph doing? The graph is getting closer to -1. In fact, it's becoming -1. All the values from left, it's going to -1. From right, it's going to -1. That's what I say. Oh, so that is the limit.
So, sir, yeah,
Hello.
sir, to find x intercept, how can you know that using the x is x squared minus 2 not
Looking at where has it touched the x? It's on the right of -1. This interval is, these questions are saying x is less than -1 or x is greater than -1. Where are we? If you're talking of this interval here, you can't think of it as being less than -1. I mean, less than -1 is this side, but we are talking of this side. So I can't pick this. I have to pick the one that is being used when x is greater than -1.
Okay, sir.
Hello.
So on that, the second thing, you have to show those to my arrows, like approaching the -1
Maybe if you don't,
and the graph.
okay. So today we'll leave it here. Tomorrow, the question we are starting with is integration. I hope you join early. Because we have integration by parts, and then integration from partial fractions, and then implicit. Then application of differentiation, the sketch, increasing, decreasing, critical points. So I hope you join early. tomorrow. And then we'll have matrices. Then binomial, logs, irrational, sets, absolute value, sign, and then domain and range.
So,
Hello.
yes, so how often do they bring plotting? Let's say they've asked you to plot for, for tan. Does
Not
that
so
question
often.
usually come? Hello?
Not so often.
Oh, okay. So thank you.
Because I also tried to check for the questions, I couldn't find one.
Yes, they're not common. They're not liked by examiners. So don't run up. So you have a good night. You need to, the timetable is in the group. So you check on the group description. You have the timetable. Thank you for attending.